I'm honored to introduce our next speaker, Zhamak Dehghani. She is from the United States. She is Director of Emerging Technologies at Thoughtworks. And she will talk about data mesh, which is a new definition of how we think about big data analytics. Hello, Zhamak. Your microphone.
Hi. That was one of the most accurate pronunciations of my name, so thank you for that.
Oh, I thought I was muted and I was not going to say anything. You're very welcome. I was looking at some of your talks. I feel it, and I always think it's a very important thing to pronounce names well, so yeah, I prepared.
Thank you.
Zhamak, I think you can start, Zhamak.
Okay.
Yeah.
Okay, perfect. Can you see my screen okay? There's no pictures hovering over it or anything?
Yes, we see you and data mesh, the presentation.
Okay,
yes.
Perfect. Well, okay. Well, thank you everyone for joining. I actually prefer to stay back and listen to that wonderful DJ music that was playing, but here we are. Let's talk about data mesh for the next 30 minutes. I want to introduce the concept to you today and explain a little bit of the rationale behind it, why this concept came to exist, and a little bit of how. We only have half an hour, so let's see how we go. What it is, really data mesh is a decentralized approach to really manage and access analytical data at scale. So let me break down this phrase a little bit for you. What do we mean by analytical data? And I want to kind of emphasize in this presentation that really the inspiration for data mesh was satisfying access to use cases that fuel our analysis, whether it's statistical, predictive diagnosis analysis, our visualizations, training machine learning models, right? A new set of requirements, a new set of kind of access modes to a historical and temporal view of the data. And this really the emphasis of the data mesh is not so much the operational data, but there is a close relationship between the two. Where do analytical data live today? Well, today we have this great divide, right? We have our operational data or transactional data, sometimes we call it, which really keeps the current state of the business on the left-hand side in this yellow kind of operational data plane. This is where your microservices are running, your legacy systems are running, your SaaS products are running, and as you satisfy the needs of your business and serving your APIs or functionality capabilities, you keep the current state, right, in the database, and often transactional databases. And we call this data on the inside, the data that is not supposed to, by definition, be accessed by anybody but the logic of the application, and it's there to serve the logic of the application that's serving the business. And then on the right-hand side, we decided that, from kind of half a century ago for business intelligence reporting, and I guess more recently with training machine learning models, we need to have a new view of the data. We need to have this kind of aggregated view of all of this data that's happened at different points of running the business and look at it with a temporal view across the time horizon. And this historical aggregate view, we ended up deciding that for some reason we need to put them onto a data warehouse so that we can run SQL queries on them, or put them on a lake so we can keep, access the files as close as possible to their original format. And we call this data on the outside, and then we hang off training machine learning models or reports from this analytical data plane. And we've been kind of keeping these two planes separate for a long time. And really, data mesh challenges this approach to managing and accessing data, analytical data, at scale. So what does the scale mean? I think for now decades, we've seen this scale across these different dimensions. So in the early 2000s, we see the scale across the volume of the data, right? So we did have like the Hadoop ecosystem to take care of large volumes of the data. We did see the variety of the data. So we moved from kind of just relational tabular view of the world to the file view of the world, to store images, to store audio. So we've experienced that. And then we experienced the velocity of the data with the introduction of the mobiles and various devices streaming data. We introduced the streaming technologies to take care of velocity, and we probably had a couple of more V's around kind of veracity, quality, and so on. And I think we're now facing a new kind of scale, and that scale really is about proliferations and the scale around the origin of the data. Where does data come from? And a scale around our aspirations, how to use the data, right? So the use cases that we can fuel and use analytical data for, it's really diverse and it's growing with the data-driven ambitions of our organizations. And where the data comes from, it doesn't really localize to one business unit. It's across the organization, across every touch point with our customers. And it's beyond the bounds of our organization. Like, I'm sure any of you that are working on data-driven kind of solutions, you probably get data from your partners, from market research, from within your organization to simply train a single machine learning model. So how do we handle this diversity? And I think that's really requires looking at our approach so that we can handle the diversity proliferation with high speed of response, right? So we don't slow down as this scale grows. And data mesh is really stepping back and looking at what are some of those accidental complexities? What are those assumptions that we've built in our solutions that we need to kind of revert back? If you guys have read the famous paper by Fred Brooks, if I remember correctly, it's not a silver bullet, and he talks about accidental and essential complexity. I think on one hand, our organizations are growing and we have some essential complexity around that diversity of use cases and the origin of the data and the diversity of the data. But on the other hand, we have this accidental complexity, which is a result of how we've designed our systems, and we can fix that. So let's look at some of these kind of shifts that data mesh tries to make. And the most important one is architecturally. And I know this is a simplification. This is a 50,000 foot view. Architecturally, it actually moves away from this idea of that we need to have a monolithic or centralized place for data. And when I say central place, I don't mean physically on the same disk or in the same kind of storage location, but it means architecturally we've decided that you have your data team that's supposed to get data from all of these sources, and then through some sort of a labyrinthine pipeline, put them into a lake or warehouse and then serve the consumers. A monolithic architecture is easy to start with, right? Anybody who built applications, monolithic applications, are familiar with this, that they're really easy, simple to start with, and they're painful to scale because how do you break it apart? How do you break it apart in a way that you don't step on each other's toes, right? And grow it. And this idea that the data needs to be the other concern that data mesh really challenges is that we've got to have this data team, often very frustrated, very unhappy people that are responsible because they know they're tooling around data for putting the data all from all of these domains into one place. So if you're a digital streaming business, you have part of your business dealing with podcasts, part of your business dealing with your artists and payment, part of your business dealing with kind of your listeners. So all of that data that those businesses on the left-hand side generate have to be centralized so that the people on the right-hand side can use. And I have intentionally drawn the facial expression that I think often people demonstrative of the feeling of these groups, because people on the left-hand side often have no intention or responsibility or accountability for sharing the data that people on the right-hand side need, people who actually need to use the data to train the machine learning, to train the recommendation system and so on. And they delegated that responsibility to a bunch of people that are not really embedded into the domain, they really don't understand what's going on in those domains, what's going on with our listeners or player applications, but they're responsible for some reason to receive that data and then collate it and aggregate it and cleanse it, make sense of it and put it in one place. And people right-hand side are all utterly frustrated because their experimentation with data always delayed, requiring someone central to take care of their needs. So then what do we do? As architects, our job is kind of break down big monolithic systems into smaller parts so that the parts can move faster. And one way to break down your architecture into smaller parts is around its technical capabilities, technical partitioning. So I've seen in a lot of organizations when we reach this space, we say, okay, let's have an ingestion team that really focus on the ingestion services. Let's have the processing, let's have the serving team. But the challenge with this sort of technical partitioning is that we end up with teams that are really activity oriented and not outcome oriented. And an activity oriented teams are teams that are working on ingestion and so on. The challenge with that is that so going back to this one, that the change really to get an outcome is orthogonal to this decomposition. So if you need to have access to a new set of data, you probably need to make changes across these pipelines. Yes, you do optimizations to some degree to get reusability out of each of those functions, but ultimately getting data from the source to the consumer requires lockstep changes to the middle, which means you're still going to be slow in responding to change around consumers or providers. And really, the problem comes down to this. As we see growth and complexity in our organizations and their needs for data, the big data platforms become a bottleneck. So what do we need to do? So I just think really, I hope that the last kind of few slides describe the why, as in why data mesh, but really the origin of this started in 2018, when we started talking to a lot of our clients. I work for a consultancy company, so we do software development for our clients. They kind of came to us and said, give me the next silver bullet data strategy. I've done the warehousing, I've done the lake, I've done it on the cloud, and I'm still not getting results around these problems. We're still either trying to kind of, when our organizations scales out in the number of domains, and these were kind of sophisticated, complex organizations in retail, in healthcare, in kind of tech, they're really failing. They're feeling that pain that I just talked about in the previous slides. And ultimately, they get stuck in this kind of cycle of bootstrapping the next big data platform and really failing to materialize the value of the data, compete with the data. And when you look at the industry metrics, I mean, this is one report, but you can choose your report of choice. But Vantage Partners that talk to a lot of executives, what we see is this disproportionate amount of money that is being spent in the AI and big data space for, the next kind of shiny tool. And we're not seeing the outcome, right? Be able to really compete on data and use data to change our business. So I really think we are at a pivot point. Pivot point is a place in your kind of graph that your slope changes from one direction to another direction. And if I look at this slide, on the x-axis of this, I'm seeing the growth of scale in business complexity, what we just talked about, in the origins of the data and source coefficient, in the diversity of expectations. And on the y-axis of this is the impact of that change. So we have a choice that how do we want our approach impact our agility, our response to access the data, satisfy new hypothesis based on data? Are we immune to change? If a data source changes upstream, are we constantly running around fixing downstream data pipelines break, or are we actually immune to that sort of changes? Are we getting value from the data? And really, data mesh, my hope is that it's the approach that comes after the inflection point, so that we can really get result at scale from our data. So how do we go about building this decentralized kind of approach? And I want to start with kind of the principles here as the things that we need to consider. And this is not just an architecture or just a technology that you can buy or just organization. It's really a kind of a well-rounded shift that needs to happen. And the first most important part is handle complexity by breaking down a complex system to its parts in a way that those parts can still function with autonomy, with least amount of interdependency. So that's why I call it the domain ownership or domain-driven data ownership and architecture. So the very most important, I think, principle of data mesh is that The same, follow the path that we've been on with the introduction of the work of Eric Evans that said, okay, if you're dealing with a multi-team complex organization, and our organizations are complex systems, let's try to model the software, the capabilities around what constitutes those parts of the business, not this manufactured accidental complexity of ingestion and serving or warehouse or lake, but really what constitutes the parts of the business. That's your artist management, that's your players, that's your marketing, sales. This is what constitutes the organization units. So then follow that and say why those organizational units can't be responsible for their data, for analytical data, for data that can be shared reliably for analytical data purposes. So that then arrives at a data ownership model and an architecture. Data as a product is a second principle, is that, okay, how do we actually make sure that we don't end up with a bunch of data silos? So these domains happily own their data, but nobody can really use it. So data as a product introduces both, again, an approach, a set of roles, a set of expectations, as well as an architectural unit that allows this data now, this domain-oriented data, can be shared as a product that delights the experience of its data users directly, the analysts, the data scientists, the data-driven app developers. They don't delegate that to a third-party data engineering team or data team to turn it into a product. It gets turned into a product right at the source. And then self-serve data infrastructure is really looking at what are the gaps we need to fill so we can arrive at this autonomous, kind of nirvana of these different domains responsible for sharing and building their data products. What do they need to actually have that autonomy? And finally, how does the governance need to change? If you're talking about a decentralized model, what sort of governance concerns need to change to be real, right, to actually make this work? And I think there are three parts to it. I put two of it on the title. And one is the governance model needs to be federated, needs to be embracing this federation of domains, and needs to be computational. It has to be embedded as automated computations into every data product. So let's look at some of these. So as I said, the distributed domain analytical data ownership comes back to the work of Eric Evans. So I encourage you to kind of study that. I put some of the contexts that are relevant to data mesh, which is the bounded context, discovering the boundary of these data products, discovering the ubiquitous language, the model for that data product, locally describing that, and then doing any context mapping. If my listener's data product has a relationship, a semantic and data relationship to, let's say, my playlist data product, because the listeners built their playlist, then create that as direct kind of links between the data. So context mapping, there's a bunch of models or patterns that we can apply from domain-driven design to build our data product. So now this big monolithic blue box of warehouse or lake will turn into now this separate independent bubbles of your domains. Some of these data products are aligned with the data domains are aligned with the source. Some of them are aligned with the consumer, and some of them really aggregates, right? So the subscribers perhaps or listeners are these aggregate domains that get attributes from different domains and creates an aggregate for reuse. So then your bounded context of your domain, let's say your podcast domain now, not only which constitutes of teams and systems, and it's kind of an architectural view and organizational view, not only providing a set of capabilities, this is my lollipop notation means APIs, right? Not only providing operational capabilities and data, like for this listener, recommend to me the next playlist. That's an operational capability, but also analytical data for this listener. Give me the historical view of what this listener has listened to, for example, over the last month. And this is an example of those DNO lollipops, which is in podcasts, for example, podcast demographics, listeners demographics is an analytical data set. Top podcast daily is an analytical data set that domain now provides for its own use and others' use. And also, you have your normal APIs and applications, create podcasts, release podcasts, also part of that domain. So then how do we make sure that this data actually is usable, right? It's just not now a siloed, unusable set of data sets. And I think the most simplistic way of articulating and start thinking and imagining what data product could look like is using this Venn diagram from Marty Kagan, which basically said every successful product fits at this intersection of being usable, feasible, technically business-wise, and valuable. So let's just look at usable as a starter. What does make a data product usable? So I use this notation of kind of hexagons in my diagrams to indicate a data product as a thing, as a physical thing on your architecture. And these are some of the capabilities that intrinsically, intentionally needs to be built into every single data product to be reusable, right? Imagine, put yourselves in the user of a data scientist. Well, I need to be able to discover, I have a hypothesis. Does the weather forecast change affects the way people listen to music? I need to train a model. How do I validate my hypothesis? Well, I need to first find, do we have any weather information and listenership behavior information? So I need to be able to discover data. Once I discover it, oh, it looks like we have something about what listeners listen to. Let me understand it. Let me look at the documentation. Let me kind of play with the notebooks that are available to me to see what behavior it has, maybe some visualization of the data. Let me address it programmatically and securely get to it and then start using it. But you know what? This listener information, I need to join this to another data product that tells me about my listener's profile. So the two data products need to have a level of interoperability and standardization. So these things that can be joined together, right? And the list goes on. But I think the one that I really want to emphasize, which flips really and inverts our model and modeling of data, is this natively accessible. So if you pay close attention for each of these products, I've indicated that they provide, again, yet another lollipop, which means it's an API and interface to access data in a multimodal way. Because if your first class concern is this data product around the domain, the same data product get used very differently today. Just again, I think it's also a result of accidental complexity, but we have to accept reality at some point. And that is that we have multiple camps in tools and how people use data, right? You've got your SQL camp, and you've got your streaming camp, and you've got your data frame camps and columnar file camps. So you've got to, if you start today, you've got to deal with that. And that the only way to deal with it is that I've got this domain-oriented data product. I need to expose the same semantic of data with different modes of access. I need to allow my report people run SQL queries. Also need to allow my data scientists to walk through the columns and use the data frames to do whatever transformation they need to do. So you end up with this same data product, multiple access points to provide different native mode of access for different personas. So then what's this hexagon architecture quantum? Well, the hexagon in my mind is the most revolutionary aspect. If we really internalize it, and I know I'm just only scratching the surface about data mesh, is that we are now looking at something different than bits and bytes on this, something different than just files, or something different than just tables. And we're looking at now a new unit of architecture that in itself intentionally can have all of its structural components to be that autonomous, reusable kind of data product, right? So what is this architectural quantum? What is this unit? And I think it's the data with a heartbeat. It's the data. Of course, we talked about the data. It's this metadata, essentially additional information that makes that data trustworthy and usable. Like, what are my SLOs around integrity or timeliness of the documentation, schemas, and also the code. Most importantly, the code that makes this data actually usable, data product usable, transformation, policy execution, serving the data, and also the sharding of the infrastructure where I can run this thing. That gives me all of the pieces I need to now have an autonomous kind of data product where the code and data kind of maintain together. Again, this is a logical grouping of a logical architecture unit. So internally underneath this, your data might be still kind of across like storage, physically co-located, but from the experience of a data product developer, somebody who's building this or somebody is using this, they can see this as one unit and deal with it as one unit. So then what do they need? What do they need to get to this point of having these data products? And what they need is really a multi-plane or new, this is just a fancy way of saying a new group or categories or classes of self-serve data platform capabilities. And again, I use the notation of lollipops because I want to emphasize that the job of the platform is building that surface which abstracts complexity behind it and give a set of APIs that really satisfy the experience of the data users and data product developers. So what are these APIs? I think we have this utility plane already, probably to a large degree, more or less, which is, our data transformation code, our Spark engines, our, APIs, our data observability tools. I have a bunch of utility layer capabilities at the moment. But really, if you look at the data product developer kind of journey from incepting and kind of going from that hypothesis, like that I gave an example to you a few minutes ago, to source the data, to explore it, to now bootstrap building a new data product, to build and deploy it, to maintain the life cycle of that data product and finally retire it, maybe. What do they need? And they need a new set of capabilities that to manage at least at the minimum, to manage the life cycle of that data product. So they need easy declarative way to build their data products, to be able to version it, to be able to secure it. And then if you join all of these data products together, we need a new set of capabilities to give us that mesh level experience, right? So we can actually search for the data products. We can browse them. We can kind of look at their lineage graph or knowledge graph of all these graphs that can emerge from this mesh. So that kind of gets us to this multi-plane set of infrastructure capabilities. But let's get real. This is going to be complex, right? So I talked about accidental complexity and kind of essential complexity. I think to meet the scale and diversity of reality of today, we are introducing complexity into the system, but it's not so much of an accidental complexity. It's just complexity that is essential to run a planet scale kind of operation and satisfy our data needs, right? So how do we make it real? How do we make it that actually these pieces talk to each other? And I think we need a new mode of governance. The objective of the governance at the end of the day really is about, it remains the same. How can we make sure we provide accessible, trustworthy, secure data at an organizational level, right? Or beyond the organization if you're sharing your data in a marketplace or with your partners. And to me, really, this idea of federated computational governance is about maintaining an equilibrium between centralization and decentralization. So embracing the fact that domains have autonomy over the data that they generate. They have autonomy over the modeling of the data. So we have to kind of this domain sovereignty and control of the domain that has to be embraced. Secondly, we have to focus on a new set of kind of capabilities around standardization and interoperability of these data products. We've got to embrace that this is dynamic topology. So any governance model that requires you to put your system in a straitjacket of some sort of a global canonical modeling is just going to be really, really fragile because data products continuously change. And guess what? They're not going to be under the one schema, ruling schema in a warehouse anymore, because that didn't work. That was a, blocker. So how can we make sure that we have the right versioning, the right kind of, change control so that we embrace kind of this dynamic topology of the data products. And finally, we are thinking about, this is a magical moment. Like when we're at this pivot point, this is when we can imagine the future differently, right? Because we're departing from the past and past approach. So now we have this possibility of thinking about your data infrastructure in a different way. So now how can we automate all of those concerns that the governance has around security, around accessibility, around compliance, embedded in an automated fashion into every single data product? And that really comes to this idea of the idea that, the data governance function needs to be composed of those people from the domains, so data product owners and domains. So they have a stake at this, and it requires some sort of an incentive model that these people not only care about the growth of their own data product and its usability and so on, but also care about this. They are a good citizen of the mesh. So, have this kind of federated model of decision making, as well as defining what policies need to be applied in a consistent way, like the minimum set of policies that need to get applied across all of our data products. Let's automate that configuration or ability in our platform, and let's embed part of our platform into every data product. I mean, the fascinating thing is that we're moving away from just data as a static thing to data product, which is a live thing. So you have this opportunity to really embed execution engines into your data products, the same way we've done in Service Mesh. So this is definitely inspiration taken from Service Mesh. So in short, data mesh is really three things. You are bringing, remember that yellow and blue operational analytical plane, you're bringing those planes together closer to each other, divide them around domains, get every domain team to not only own their microservices applications, but also their data products, and introducing this new kind of unit of your architecture, quantum of your data architecture, data product quantum, defining its interfaces, defining its container that really runs it as a separate piece, responsible for sharing data for a domain and connecting it. Creating that multi-plane data platform that allows this autonomy of the teams and the data products to run cohesively as a mesh, and create this federated kind of computational governance that takes advantage of that platform, takes advantage of the data product to embed like access control into every one of those. And we've done this with zero trust architecture, right? These are not new concepts, maybe new to how we imagine kind of big data analytics. And it's really both an organizational change, architectural change, and of course requires a change to the technology that we have today to satisfy it. I just scratched the surface, so hopefully that was helpful. If you want to learn more, there is a grassroots data mesh learning Slack channel that you can join your peers and talk all about data mesh and learn from each other. I also run a 16-hour immersive workshop on DDD Europe. You can check that out in September. And my book hopefully comes out later this year. So in a few weeks, I will have the early release on O'Reilly. And hopefully you find all of that helpful. And guess what? I'm 29 minutes and 59 seconds. Done it in 30 minutes. And let's get to any questions that you have.
Amazing timing, Zhamak. Thank you very much. It's a very, very interesting topic. To me, it feels like this very much taps into what Trond has been talking about earlier, which is domain-driven designing and having nice borders and modules. And it seems like it also requires a change in organization, as you just said in the end, that companies have to change the way they think about data, and that means they have to change how they structure their teams. Because currently, you have teams that one team that does all data. And it really reflects how we also have centralized data lakes, right? And my question is, like, you have all this tooling today you have all the Apache tools, and you've got BigQuery and all these big guys creating all these cloud tools. Does this require new tooling, or can companies reuse the same tooling, but in a different way?
It's a really good question. So we have no choice but using the existing tooling right now for a short time. I think if I look into my crystal ball and also learning from experience of building this for our clients, in the short term, we'll be using the existing tools that we have. So, for example, I talked about that data product as a unit. So if that data product has some code inside it that does transformation of your data from upstream and then serving it, you probably use, if you bought into using Spark, you probably use the Spark for that. But then the API to serve that data, you may need to kind of run your own services to encapsulate not so much the data itself, but the additional information about that data to get access control to the data. And I know as Spark folks, Databricks folks have come up with kind of new products around that as well, and new standards around data sharing. So you need to kind of use what exists today and stitch it together, spend a lot of time, stitch it together to give an illusion of this independent unit of deployment. It's not as nice as like having a single container and deploying it, right, with the microservices. But I think that, and then within that short period of time, hopefully the next kind of short few years, what we find is that the providers will need to reconfigure their tooling to satisfy a multi-data product world. Because at the moment they thought, you have 1, 2, 10 lakes. They never thought you will have hundreds of lakes, like when you use their services.
Right.
So they need to change their configuration. So I think that's where you can get started today. But my hope is really for us and for the tool makers to start reimagining. We're in this centralized multi-cloud world, where compute needs to come to data. So with these data products, not always data moves to another data product for compute. So in many cases, actually compute comes to the data. In some cases, it's on the consumer provided. So I think we will imagine new set of tools.
Right.
And that's my.
And by the way, I encourage everyone to ask questions. I haven't checked them, but yeah. We have 2 questions. Thomas says, regardless you call it monolith or data mesh, you end up with a pretty big deal of connected technologies. Becomes very complex alls. Are you aware of technologies? I think I just asked the same question. So yeah, I'm going to jump to the next one. Gabor asks, if I understand correctly, every business team responsible for a domain now should be able to create data products for their domains. In other words, they all need data experts. Do you think this is realistic for organizations to invest so much more? I think it's a good question. So much more into data analysts, because it will require growth of data analyst teams, right?
Yeah. I think we are being very hypocritical at this point. We claim that we want to be data-driven, and we put all these nice mission statements on the wall about being data-driven, and we're not yet investing in data literacy and enabling our people. But you are right that while I expect to have new roles in every domain, data product owners, that their accountability is knowing their data and sharing that data based on the needs of their customers, we can't expect people to have to go from today to have data engineers, this skill sets that we expect, and they're so hard to find as well, because we try to hire data engineers. Go from where we are today to have those skill sets available to every domain. And I think this is where that opportunity lies for that data platform, to really abstract the complexity of technology that exists today, to make every generalist developer have a path to be able to provide those data products. And we've done this, in fact, with our clients. We have 150 or more data product developer on our clients, but at a particular client. But we only had a handful of traditional data engineers. So we had to kind of abstract away some of the complexity to create a path for cross-skilling from a generic, maybe expert generalist, from an expert generalist to a data product developer. And that both of those need to happen.
Right. You have to spend to do it right. That's okay.
Sorry, just one last thing. We've got to break down the wall. I mean, we had this problem of the wall between dev and ops, and what happened? We brought down the wall and we generated a wonderful new generation of SRE engineers, right? A new type of engineers, and we've got to break down this data wall so that we can cross-skill our people.
Right. I just want to ask lastly, do you actually work on implementations and tools at Thoughtworks that you want to outsource anytime soon? And do you also do consultations for companies to how to reorganize? I guess you do both, right? Or you're planning?
Yeah, we do both. So we don't have products, unfortunately, at Thoughtworks, and we haven't open sourced anything, despite the fact that we have built quite sophisticated systems that implement those data planes for our clients. I must say that we're only a few years into this. We started actual implementation in this mode. I mean, we've done bits and pieces of this in the past, and that's what we had learned. But in the data mesh, in this incarnation of it, only for 2.5 years. So we are still early at this. So we've got to accept that. So all our development is IP of our clients, and our clients may not choose to open source. So fortunately, at this point, I think that my focus will change over the next year. I will be focusing on more of the tooling and open sourcing the tooling, and the consultancy. Yes, we.
Thank you very much, Zhamak. I think this is an amazing direction in data science.